Welcome to another session in our series of tutorials in R for data science. And in this session, we are going to look at hypothesis testing. And hypothesis testing is the way science in general works. So we test a certain experiment at a certain alpha value or a certain significance or a certain confidence interval. And in this session, we're going to look at, or under hypothesis testing, we'll cover the t-test, the z-test, and the chi-square test. In both the t-test and the z-test, we are working, or we are talking about the mean. We are saying, is the sample mean equal to the population mean, or is the mean of that sample equal to a certain presumed mean? And we will define our hypothesis. That's the null hypothesis and the alternative hypothesis. So we are testing to reject the null hypothesis, and if the probability or the p-value, or if the p-value is less, or it's very small, that is, it is less than a certain threshold, and this threshold is our alpha value. So if the p-value is less than the alpha value, that means we reject the null hypothesis. And if the p-value is greater than the alpha value, we fail to reject the null hypothesis and conclude the alternative hypothesis. So we first of all define our hypothesis, then we decide, we choose up front, that is the alpha value, the value in which we are going to test whether to reject or to fail to reject the null hypothesis. So in this session, we are going to look at the t-test, and in t-test we'll look at one sample t-test, the paired t-test, one-sided t-test, and two-sided t-test. And we'll be using the tidyverse package. So we'll use tidyverse package for data manipulation, and we'll use the data set that comes with the ggplot, that is the diamond. So we first of all have to install the package tidyverse using the command install.packages, that is the tidyverse package. I've commented this line because I've installed the package. And then we'll load the package using the command library tidyverse. Then we'll be using this dataset, the inbuilt dataset called diamonds. So that means you can as well practice this dataset on your own using this dataset called diamonds. So let's see how the dataset looks like. So here is the dataset. It is diamonds. It's a diamond dataset. So if you want to know more about this dataset, you'll type question mark and then diamonds. So you'll type question mark and then the diamonds. The help command, it will help you here, and here it is the prices of over 50 round cut of diamonds. That is it. You can find the full information here about this data set, including the usage. So what we're interested in this data set is we're interested in the price and the cut. So, and in one sample t-test, we are testing is the mean of a certain cut of diamond, for example ideal, is the mean of ideal diamonds equal to a certain value? Is that statistically significant at a certain alpha level? If the probability of getting that's using our null hypothesis, for example here, the null hypothesis here is saying that the mean is equal to 3000. So it's good that we understand hypothesis testing first. That's because that's for the t-test, chi-square test, and z-test will be using hypothesis testing. So let's first understand hypothesis testing. So we are saying is the mean of a certain sample equal to 300 or equal to 3000 or equal to a certain value? What is the probability of us getting a value? Or what is the probability of us getting that the mean is equals to this value? And if the probability of us getting a mean equals to this value or equal to a certain value at a certain alpha level, if that probability is very small, that means that we reject this the null hypothesis and conclude the alternative hypothesis. So basically that is how science works. So here I'm testing is the mean of ideal. So here I'm using the ideal cut. Is the mean of diamonds with the cut ideal equals to 3000, or is the mean not equal to 3000? So I'm testing at 5% significance level. So let's look the t-test. So this is how to perform the t-test. We use t.test. So, and because we are performing one sample t-test, we are performing one sample t-test. We are defining this mu. Mu is the non-mean, is the mean that we are trying to test. Is the mean equals to this? Is that statistically significant or it is just by chance? So I'm using the diamonds data set. So I'm saying diamonds, and then I use the pipe operator. This pipe operator, what it does is that in the second function, which is filter, what it does is that it takes this value, it cramps it as the first argument in the second function. So I'm saying diamonds, I pipe it to filter. So I'm filtering whereby cut is equals to ideal. So I want the observations where cut is equals to ideal. I pipe it to select. I want to select the price, and then I pipe it again to t.test mu is equals to 3000. So this t.test performs a t-test on this data set. So it is testing is the mean of price, is the mean price of the cut diamonds, ideal diamonds, I mean, equals to 3000. So, and here I'm using double equal signs because I'm asking the question. I'm saying I want all observations where cut is equals to ideal. Let's run that. Now is the most interesting part. So we look at the p-value, we look at 95% confidence interval, and we look at the sample mean of x. Now don't forget we are testing this basing on our hypothesis. Now our null hypothesis was saying that, or stating that the mean is equal to 3000, and our alternative hypothesis states that the mean is not equal to 3000. Now what's our p-value? The p-value is very small, 2.2 times 10 raised to power negative 16. So it's 0.000000000000002. It's a very small. So that means if the p-value is less than 0.05, we reject the null hypothesis. So we reject this null hypothesis. We reject the hypothesis that the mean is equals to 3000. If we reject the null hypothesis, that means we accept or we conclude the alternative hypothesis. So here we conclude that the mean is not equals to 3000. So basically that is one sample t-test. And if you understand the one sample t-test, then the other t-test will be very easy. Now let's go at the two-sided t-test. Let's look at the two-sided t-test. Now in two-sided t-test, we are asking, is the difference between the means equals to 0? Is this mean? Is the mean, or is the difference between the means of two categorical variables different? Now, so here we'll use the premium and the ideal diamonds. So I want to test, is the mean, is the difference. So I'm not interested whether the mean is it positive, is it increasing, or is it decreasing, or which one has a greater mean. I'm not interested in. What we're interested in is just the difference. The difference can be negative, the difference can be positive. So is the difference between the means equals to 0? That's the question we're asking ourselves. Now, our null hypothesis is the mean difference is equals to 0. So we are saying there is no difference. There is no difference between the means. Then the alternative hypothesis, the mean is not equal to 0. Here is the code. So I'm saying diamonds. I'm using the pipe operator still. I'm filtering whereby cat is equals to premium or ideal. So I want the observations. I want the observation in the diamonds data frame whereby the cat is equals to premium and ideal. And I'm using, I want where cat is in. So this cat is in premium and ideal. Then I'm using the t.test command. I'm saying price as a function of cat. So I'm saying price should be modeled as a function of cat. Then I'm saying data is equals to dot. So this operator here is called tilde. So it's price as a function of cat. Then data is equals to dot. That way. This means that in general, the t.test command t.test, the first argument in t.test should be x, and x is or should be a data or a data frame or a vector. But in our case here, we don't have that because we have used the pipe operator. What this does is that R understands that when we say data is equal to dot, it crams this as the first argument here before price. So that is what it does. Then I'm saying alternative is equals to two-sided. So we are comparing the premium and ideal. So our alternative is two-sided. And the confidence interval is 95%. I can as well get rid of this, or I can as well leave it the way it was, because the default in performing t-test is 95% confidence interval. I run that. I run this. Here it is. Interestingly, the p-value is very small. The p-value is very, very small. Our p-value is very small. Our p-value is very small. It's 2.2 times 10 raised to power negative 16. So that means we reject the null hypothesis. If we reject the null hypothesis, we reject that the mean is equals to 0. So we are rejecting this. So we are saying the mean difference is not equals to 0. And it's also giving telling you alternative hypothesis through mean, the true difference in means between groups and group ideal is not equals to 0. Here it gives you the mean for premium, and it gives you the mean of ideal. And this value, this 95% confidence interval, also does not include 0. So that is 1, two-sided t-test. Let's look at the two-sided t-test. Let's look at at one-sided t-test. Now, in one-sided t-test, we are testing is the mean of premium diamonds less than the ideal diamonds, or is the mean of premium greater than ideal? So it's an advancement of two-sided t-test whereby we are testing which one is greater, which one is less than. So our null hypothesis here is that the premium diamonds have means less than ideal, and our alternative hypothesis is that the premium diamonds mean is not less than ideal. That means premium diamonds have a mean that is greater than ideal. So still we are using the diamonds dataset. So I'm saying diamonds. I'm using still the pipe operator. I'm filtering where cut is in premium and ideal. I pipe it to t.test. Price as a function of cut. Data is equals to dot. Then alternative via alternative is equals to less. I'm asking a question. I'm testing my null hypothesis. Is premium, or is the mean of premium diamonds less than ideal? Let's run this. The confidence interval is 95. You can as well change this one to 99 or to any value you want. Let's run that. And interestingly, let's see, our p-value is 1. This p-value is greater than 0.05. What does that mean? It means that we fail to reject the null hypothesis. We fail to reject this. We fail to reject this null hypothesis and conclude that premium diamonds have a mean less than ideal. So that is the two-sided t-test. Let's conclude this with a paired t-test. So in the paired t-test, you're testing the same variable under two different occasions, or under two different scenarios. For example, in medical research, whereby we are testing the level or the condition or the headache of a certain patient before and after giving them a certain medication. So we may test the level of headache of patients before giving them the medicine, and then we measure it. Then after giving them the medicine, we test the results, that is after giving them the results. And then we are testing, we are saying, is there any difference before and after? So our null hypothesis, there is no difference in means before and after. So that means it's just the same. Then after, or the null hypothesis saying there is a difference in means before and after. So let's run this. I'm creating a data set here, before and after. So I'm using t.test here, and I'm saying after and before, and I'm saying paired is equals to true because this is paired. Let's run this. Unexpected symbol. T.test. Object after not found. Okay, let's run this. Then let's run that, and here we are. Data. Now the p-value is 0.000015. So it's very small. That means this p-value is less than 0.05. So that means we reject the null hypothesis. We reject this hypothesis and conclude that there's difference in means before and after. That means there's a difference between before and after. And it's saying that the alternative hypothesis, true mean difference, is not equals to 0. So that is basically all you need need to know about t-test. So in our next session, we'll look our next class under hypothesis testing, we'll look at chi-square test. Thank you. Enjoy learning.